In this session, we are going to discuss about the dynamic routing concept. We have discussed about the static, where we are going to make the entry by itself, by us, by administrator, when there is a millions of the routers available all over the world, and already you know there is a trillions number of the IP addresses and millions of the network are there. So making the entry static on every router is not possible. So there is a dynamic routing concept is available where routing table has been created automatically. So we will discuss in this session how it is possible and how can we do it. So first we need to know about the dynamic routing protocols, because when everything will happen automatic, there is a required protocols. Yes. So actually the dynamic routing protocols, which is making the entry in the routing table, that has been learned from the another router by a dynamic routing protocol. So dynamic routing protocol will help to creating a routing table to exchanging their information with one router to another router. So this type of the routers are exchanging their routing information and they are creating the base system. Base, where is the information of the routing tables, available routes and other information. Once the one router will learn the information, it will share the information with other routers. First, every router will learn the routes with the nearby router. For the example, there is a router which having some information. It will share the information to this router. If there is another router, so it will forward the same information to this router. So in this case, every router will learn with each other and they are creating their own table and the database as well. So on the behalf of the different matrix and topology can be used. Means creating the topology for the fastest route, means which route is fastest. So, and it is based on the matrix, means some algorithm are used to making the matrix and finding the shortest path and best path and then create a topology. Topology means arrangement of the devices. So there is a two types of the matrix are available. One is a distance vector matrix, another is a link state matrix. Distance vector, where they are counting the hop count, means if there is a two routes, one route have the 10 hop, another route have only the 5 hop, so this route will be used no matter between the distance. Like if there is a only 1 meter distance, again 1 kilometer distance, again 1 kilometer distance. So this distance only the 10 kilometers, but this have the 100 meters or the 10 kilometers each. So there is a 50 kilometer and here is 10 kilometer only the range. So it will not consider the distance, it will consider only the hop count. Another is a link state. It will use the link state, means stability of the link, means the bandwidth of the link, like what is the bandwidth, 1 GB, 10 GB, 4 GB, or which type of the bandwidth is there, and a delay. Some and other also use, means mostly it will considering the link state. Means if there is a fiber optical cable and there is a copper optical cable, so fiber optical cable link will be used by the link state protocols. There is some other information like matrix access, similar routes to use the least cost path of the IP routing tables. The cost path means, what is the cost? Cost is the combination of the bandwidth and the delay of forwarding the packet. And some also other algorithm are used to determine the matrix. Convergence means where the all routers are agree on a network topology, because every router is sharing the information between each other and they are creating one topology. Then all router is agree with those topology. It is called convergence, or you can see convergence. So now the question is, how many types of the routing protocols? Yes, there is a some routing protocol is interior, some is the exterior. So when we talk about the interior, first we should know about the autonomous system, AS number. So autonomous system number means like there is a one ISP Geo. Geo is a one autonomous number, autonomous system. And here is the Airtel. Airtel is another autonomous system. Similar is a HCL or any other big company like IBM or other big ISP or the big organization. These are considered separate AS or the autonomous system. So one type of the protocol which are working inside the single autonomous number, which is known as a interior gateway protocol. Another type of the protocol which is actually making the combination or working out of the autonomous system number, it is called exterior gateway protocol, EGP. Means IGP and EGP. So it is a border gateway protocol or the border protocol which is used or making the communication between two different autonomous number. Okay. So interior gateway protocol which is using or which is used in a single AS number, routing between the single autonomous number. Exterior use the routing between the different autonomous number, means two different autonomous number or autonomous system. So for the example, here is given some protocols name RIP, EIGRP, OSPF and BGP. These are the IGP, means interior gateway protocol. These are the protocols, means RIP, EIGRP or the OSPF are used inside the single autonomous number, autonomous system, single autonomous system. Okay. RIP and EIGRP are distance vector, means hop count, and OSPF is a link state protocol, and BGP is a border gateway protocol, is a exterior gateway protocol where two AS number are there and in between there is a one protocol which will make the communication between the different AS number or autonomous system. This protocol known as a border gateway protocol, means this is working as a border. So there is a some protocol uses the classless versus the classless protocol. Some are the classful protocol. Classful protocol is a legacy protocol, means old protocol. They are working over the class. What is the class? Class A, class B, class C of the IP address. So they will work over the class. But when we talk about the subnetting and supernetting, then this type of the protocol are failed, because subnetting and supernetting working based on the network ID or the prefix or the subnet mask. Okay. So RIP having the previous version which is actually support the classless only, but the latest version of the RIP are supporting the classless as well. Previously was supporting the classful, but there is a some protocol which is supporting the IPv6 like RIP next generation, RIP NEG. This is are used. Okay, so let's move on. So distance some routing information protocol or the RIP routing information protocol is a distance vector protocol. Means when it will select the best path, it will use the next hop or the counting of the hop. Means next hop. Next hop for the A, router V is the next hop. For the router V, the next hop is a router C. Similar, if the data is flowing from this side, then for the router C, router B is a next hop. For the router B, the router A will be the next hop. And total, the data when traveling from here to here, all the number of the router will be count as a hop count. It will be known as a hop count. So where is, if there is a possible two different route, so lowest hop count will be consider the best path. So they are using the slow convergence because they are having the little bit insufficient updates, and slow convergence means when they are sharing their information it will take some time, and maximum hop count is 15. If your organization have the 20 routers, so it will not support by the RIP. So there is some other information of the RIP here. The RIP is network, and here interface, here is the metric, and here is the root wire, and here is the source means directly connected, RIP enabled here and RIP enabled here. If any route is disconnected, so the information will be removed from the routing table, and the next or another route or another route entry will be made inside the routing table. For the example, if this is broken or this link is broken, so new link entry will be this automatically. So there is a version of the RIP, is the RIP version V. It was a classful, means old version, and it is broadcasting over the UDP port number 520. RIP version 2 are used nowadays because it is the classless and it uses the more efficient multicasting. Next generation or the RIP NG is support the IPv6. These two are not supporting the IPv6. The RIP NG will support the IPv6 as well. Means IPv6 routing can be used in a RIP. Okay. So there is another protocol which is called Enhanced Interior Gateway Routing Protocol. In a short form, you can see EIGRP. EIGRP. Actually, it is an interior gateway protocol, as I have told you already, and support the classless addressing. Classless addressing means supporting the subnetting and supernetting, and use the advanced distance vector hybrid with the administrator weighted metric, and metric is used the bandwidth and the delay. Like 1 GB bandwidth is here and the delay is like 120 ms or something. So the calculation of the both will be the distance vector, all count the distance vector. Another is having the best convergence performance because it have a database which is stored the backup plans, and it is runs over the IP directly by using the number 88. Another type of the protocol which is used the very efficiency, means most of the organization are using this protocol. It is called OSPF, Open Shortest Path First, because this is supporting the multiple areas, area 0, area 10, area 20, area 30 within the single autonomous system. Autonomous system means organization. Inside a organization, there is a multiple area can be divided and all area must be connected with the area 0. So they are group, making the group related the network, means if there is a different network, for the example Geo, this is the UP network, this is a Haryana network, this is the Delhi network, So all the network also connected with the area 0. This is supporting the classless addressing, and this is also runs over the IP directly, the protocol number 89. 88 is used by the EIGRP. Okay. So there is some protocols which can be used, and another protocol is very important. It is called border gateway protocol, which is actually classed as a hybrid or the path vector, usually deployed as an exterior gateway protocol. As its name is a border means border of the two different AS, autonomous system. Different means if there is a Jio and there is a Airtel and both want to communicate with each other, so they will have to use a protocol, it is called BGP, to make the connection in between. Border gateway protocol. So different autonomous system have a unique number, it is called the autonomous system number. They are exchanging their path of the autonomous system only between one system to another system. They are supporting, or the BGP is supporting, the classless addressing. Classless addressing, as I have told you already, supporting the supernetting and subnetting. It is runs over the TCP and using the port number is 179. Different protocol are used, the different algorithm to generating the administrative distance. So here is the source, means the local or interface which is are directly connected, having the distance, administrative distance value is 0. Static route having the value 1, BGP 20, EIGRP 90, OSPF 110, RIP 120, unknown 255. So these are the different administrative distance. Administrative distance is just a calculation or the algorithm which is going to be distance. This distance actually used to prefer the path for the same destination learned by the different protocols. And also the protocol are used this metric to define the least cost path. And also they are making the entry of the route as per their destination prefix to global IP routing table. Here is the classless interdomain routing. Classless routing I have told you already. There is a some like /24/24/24/24/24, but this is also supporting the /22. It is called supernetting. So it is supporting the supernetting as well as the subnetting. Okay, here is one VLSM, means variable length subnet mask. So what is the variable length subnet mask? They are using the address space IPv4 network more efficiently. VLS actually is a supernetting. We have discussed already. They are using the same mask for all subnets. Use the different mask length according to the host number per subnet. For the basic example is here, this one. This is the example, like here is a one office, here is a office 2, 3, multiple offices are there and multiple router are there. In the main office, you have the requirement of the 80 IP addresses, 80 computers you need to connect. But when you are using 192.168.1. Here is the total number 02254, means total number is 254. So it is not enough. We need to 80. So what I will do, I will use the one address as a network address, /25. /25 already you know, when /25 concurrent, here is 7 are left. 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, the total number is 126. Yes, it can be used for the 80. For the 30 number are used. So how many computer? 4, 6, 14, 16 here and 1, 2. These will be added into the network and I need only host available for this bit. These bits will be used for the host. These bit will be used for the network. So the subnet mask will be /27. Similar cells 28, 28, 30 where you want to only connect the two computers like this, two computers only. 31 and 32. Similar, if you want to single connection, then you can use the 30. Means there is a only 1, 2. Only two computers are in the same network. Will be 30. Okay. So this is the VLSM.